Let's go ahead and take a look at solving equations using the fundamental identities. Here we have the equation sine squared theta minus sine theta equals cosine squared theta. When you're working with these problems, you want to be able to get your equation written using only one trig function. So keep in mind that we have the identity cosine squared theta plus sine squared theta equals 1. And as I look at my equation, I'm going to look to replace cosine squared theta with something that is written in terms of sine. So keep in mind we could have subtracted sine squared theta from both sides here. And in place of this cosine squared theta, I'm going to go ahead and substitute in my 1 minus sine squared theta. So let's go ahead and replace the cosine squared theta with 1 minus sine squared theta. We're going to go ahead and keep the left-hand side the same. Now, since we're working with a quadratic, we want to go ahead and get everything on one side of the equation, 0 on the other side. So let's go ahead and add sine squared theta to both sides. And I'm going to go ahead and subtract the 1 from both sides as well. So that's going to give us a 0 on this right-hand side. On the left-hand side, we're going to have 2 sine squared theta minus sine of theta minus 1. And this is a quadratic. We can go ahead and factor. We're going to go ahead and put our 2 sine of theta and sine of theta into those first slots. As we look at our factors of 1, we know it has to be 1 and 1. And we need to make sure we have a subtraction sign here in the middle. So as we look at our inside-outside pairs, we'll have to have a minus sign in this set of parentheses and a positive sign in this one. And you can double check it by using distributive property to multiply it back out to make sure that your signs work out correctly. Now we can go ahead and set each of our sets of parentheses equal to 0. And we can go ahead and solve both of these equations. Let's go ahead and do this second one first. We can add 1 to both sides. We're going to get sine of theta equals 1. Keep in mind if we're solving this for theta, we're going to go ahead and take inverse sine of both sides. So my theta value is going to be inverse sine of 1. And let's go ahead and work in both degrees and in radians on this question. This is going to give us 90 degrees, or pi over 2 if we're working in radians. If we go ahead and do the same thing to our equation here on the left, we're going to get 2 sine theta equals negative 1 if we subtract 1 from both sides. And then we can go ahead and divide both sides here by 2, and we're going to get sine of theta equals a negative 1/2. So we can go ahead and take our inverse of both sides. And I'm going to go ahead and work in degrees first. This is going to give us a negative 30 degrees. Keep in mind, you want to be working on the interval 0 to 2 pi. So this is going to equate, if we're coming down to negative 30 degrees, this is the same thing as a 330 degree angle measure. And keep in mind, we're looking at a sine value that was negative, so we should have an angle measure that is in quadrant 3 and in quadrant 4. So this 330 degree angle measure is our answer for quadrant 4. If we're looking at 30 degrees into quadrant 3, then that's going to give us an angle measure of 210 degrees. So let's take a look at some answers here. We have 3 different answers, 210 degrees, 330 degrees, and 90 degrees. And if we want the radian value for each of these angle measures, we talked about the fact that 90 degrees was pi over 2. Okay, our 210 degree angle is the same thing as 7 pi over 6, and 330 degrees is the same thing as 11 pi over 6. So we're going to have a total of 3 answers for this question.